9.4. 9.4. This is graphing linear functions. Graphing linear functions. Okay, so I introduced to y'all about functions. Remember, you could do, they don't have the same x, right? They don't have repeating x's and stuff like that. You can do that vertical line test and everything. Well, now we're going to be graphing it. No, it's not going to take a lot of paper because I'm looking through my notes right now and I'm going to skip some of this stuff.
No, for the worksheet.
Huh?
For the worksheets, I cannot paper.
For the worksheet?
Yeah.
What are you talking about?
If you
I don't know what worksheet you're talking about. Okay, what we're going to be talking about is a function whose graph is a line. Hence the word linear. You see the word line in there. So function whose graph is a line. Blah, 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 blah. I'm not going to go into that. Y'all caught up? Okay, so for example, we're going to just jump in with examples, okay? Let's say I have y equals 2x plus 3. But if it's a function, it can also look like this. F of x equals 2x plus 3. Notice the actual equation is the same. 2x plus 3, 2x plus 3. This denotes that it's a function when it looks like that instead of the y. But we talked about yesterday how it's kind of the same thing. If an ordered pair, and we remember what an ordered pair is, it's an x and a y. If an ordered pair makes the equation true when x and y values are substituted it's considered a solution. Meaning the answer. So if they ever say, what is the solution? Is the solution true? Blah, 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 blah. They're saying, is it an answer? Is it true? Does it work? Is, blah, blah, blah. Is this a solution? So I'm going to give you an example as soon as you write this down. Joseph, you got it? Okay. So, I'm still with the same example. This whole thing's an example. So we're going to take this equation. Your book will say something like y equals 2x plus 3, semicolon, is -1, 2, a solution. So here's your equation. They're saying, is this ordered pair a solution to this equation? Is it a solution? I'll put another star here. So what we do, here's your x, here's your y. We're going to substitute the x and y values to see if it's a solution. We're going to see if it's true. So we're going to substitute the x and y to see if it's a true statement. So we're going to substitute this -1 into the x and this 2 into that y. Okay, so there's your equation. They're asking if this ordered pair is a solution. This is your problem. So to check that, you just substitute into the problem. So now I have 2 equals 2 times -1 plus 3. So Joseph, 2 times -1 is what?
-2.
Plus 3 is?
1.
So does 2 equal 1? Is that a true statement?
No.
No, it's not. I'll put an X. X would mean X. So 2 does not equal 1. So therefore, it is not a solution. There's your answer. So all they're saying is this ordered pair a solution? You got to understand what they're asking. And we substituted, nope, it's not a solution. And that's what they mean when they ask you that. Any questions on that? It's pretty straightforward, right? All right, does everyone have it down? Joseph, do you have any questions yet? Okay. Okay. Finding ordered pairs that satisfy a linear function. So they're going to say, find ordered pairs that satisfy a linear function. You're going to be like, what? What does that mean? Well, I'm about to tell you what that means. The first thing you do is you're going to find at least 3 ordered pairs for accuracy in determining a line. And I'll give you examples on that in just a minute. And the next thing to do when finding ordered pairs that satisfy a linear function, so you have to find at least 3 ordered pairs. You can find more, but you need to find at least 3. Choose any 3 real numbers to represent x in an equation then solve for y. Okay, so I'll let y'all catch up on that. So choose any 3 real numbers to represent x in an equation, then solve for y. You got this, Joseph? Okay, good. Now I'm going to give you an example as soon as y'all catch up. And y'all are going to be like, basically, if you haven't noticed, my notes, it's always blah, 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 blah. And then I'll show you the example and you're like, oh yeah, okay, I got it. Yeah. Because in the math world, it is blah, 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 blah.
I thought the first word was cheese.
Cheese any three real numbers. Okay.
They're cheesy numbers.
There you go. Cheesy numbers. All right. Example. Let's say you're given. This is what your book gives you. Okay. So you're given a problem. And they say f of x equals x minus 4. And they want you to graph it. Graph this. Okay? Now, remember, what does f of x really kind of mean? No, what does f of x? What's another way of saying f of x? Y. So y, we can say y equals x minus 4. Because then you're like, oh, well, I get that. This f of x sometimes is kind of crazy. All right, so. Huh? Yeah. Okay, so find at least 3 ordered pairs. Any 3 real numbers to represent x in an equation, solve for y. So what you're going to do is you're going to make a chart. And here I'm going to put the actual equation. X minus 4. And this is going to be my y. Now, you choose or cheese any 3 numbers. They didn't give them to you like we have been doing. This time you choose them. So I'm going to choose -1, 0, and +1 because they at least 3. So I'm going to choose 3, -1, 0, and 1. Now keep in mind,
Hey, that's actually really good.
I know, right? Choose 3 random numbers. I always say to choose 1 negative and 1 positive, and 0 is easy to do. So we're going to substitute this x in here. So then I have -1 minus 4. And what does that give me, Kelly?
-5.
-5. So my ordered pair is -1 and -5. My x is -1. My y is -5. So then here I have 0. We're substituting 0 in for x minus 4. And tell you what would that be? Very good. So it's 0 and -4. And then my x is 1, so I'm substituting, minus 4. So, Joseph, what would my y be?
-3.
And good, so my ordered pair is 1 and -3. So there I've got my ordered pairs. Now I can graph. Whoops. Here's my x, here's my y. My first ordered pair is -1 and -5. 1, 2, 3. I'm just moving the thing down. So -1, and then 1, 2, 3, 4, 5. So -1's my x. Y is -5, so my dot will be here. Does everyone see that? Hopefully by now y'all are getting used to plotting these ordered pairs. Then my next one is 0, -4. So if x is 0, my y is -4. 1, 2, 3, 4. And then my last one is 1 and negative 3. So here's 1, 1, 2, 3. And there's my dots. Keep in mind, real quickly, we're doing linear functions, so it needs to look like a line. So here I have my line. I have my dots, and they are in a line. I connect them, and there's my graph. Tell me that's not bad. You just choose some random x's, plot them, and then connect the dots. Now, if you're graphing and you have like 2 dots here, and then this one was way up here, if it doesn't make a straight line, you've done something wrong. I'm trying to get that through to my Algebra 1 students who have their, like a graph can never cross, the graphs that they're doing can never cross the x-axis, and their graphs are going all over the place. I'm like, does that even look right to y'all? Come on. So if today you're graphing and it does not form a straight line, you've done something wrong. Any questions?
Like a straight line, like no curvy lines?
That's right, no curvy lines. No curvy lines. Yesterday we kind of looked at curvy lines. Today we're not looking at curvy lines, straight lines. All right, open up your book. Examples, page 366. We'll do as many as we can before class is up. Ooh, I only have 5. Excellent. And then we will continue after lunch. So go ahead, open up your books. Numeral 2. So the directions say, is the given ordered pair a solution to the equation y equals 2x minus 9? Do y'all see that in your directions? You need to probably underline that in your directions so that you see that equation. So is the given ordered pair a solution to the equation y equals 2x minus 9? So you will use that equation for all of those problems. And number 2, the ordered pair is 8 and negative 2. So what we do is, this is my x, this is my y. We're going to substitute the 8 in for x and the negative 2 in for y, and then see if it comes out correctly. So negative 2 equals 2 times 8 minus 9. So Kelly, negative 2 equals, what is 2 times 8?
16.
Minus 9.
17. 7.
So does negative 2 equal 7?
No.
No. So then your answer is no. That's all you need to write. Just no. You don't have to write not a solution or anything. That was in your notes. So for this, all you have to do is write no. Any questions about that? Let's do another. Look at number 4. Same equation, y equals 2x minus 9. But for number 4, they have you doing the ordered pair of a half and negative 8. So again, I have my x and my y. I'm going to substitute the half in the x and the negative 8 in my y. So I have negative 8 equals 2 times a half minus 9. So I'll let y'all write that. So negative 8 equals, Joseph, you want to do this? What's 2 times a half?
2.5.
Do it off to the side. 2 over 1 times 1 over 2. Okay, which is also 1. So 1 minus 9. What is 1 minus 9?
-8.
So Joseph, is this a solution?
Yes.
Yes, it is, because -8 equals -8. So then you would write yes. Make sense? Yes. Okay. So let's look at number 8. Let's look at number 8. The directions say is the same thing as we did before, but this time they give us the equation y equals -x plus 8. Okay, I want to do this one because number 8 has the order pair of 14 and -6. This is going to be weird because of this negative sign. So this is my x and my y. I'm substituting it here and here. So I get -6 equals -14 plus 8. Notice how I write that. Notice how I wrote that. Because you're substituting this x and there's a negative sign, you better make sure you put it in parentheses. Y'all see that? And that negative is in front. So Atalia, what is -14 and 8?
-6.
So is that a solution? Yes. Very good. Any questions? We're going to pause there for part 1, and then after lunch we'll do 2 more examples and I'll set you free. So this